Bitcoin Core. In this presentation, we're going to go through our second part of the project and look at the conceptual architecture, concrete architecture, divergences between those, the wallet architecture, the divergence there, and some use cases, and then end it off with a conclusion.
So the process of deriving the conceptual and concrete architecture. First, we had some source code given to us in class, on Cube, and we analyzed the source code in the Understand app, which is a tool that helps us analyze a particular system. And we looked at all the divergences and subsystems of the Bitcoin Core system. We then investigated the gaps and divergences between the conceptual and concrete architectures. And we updated the existing conceptual architecture that we had last time. But a limitation of this process is that some of the components are a bit confusing, and we weren't sure what the purpose of some of them were. So we did not cover all the details of the systems, and we had to simplify the system in our architecture. And also an alternative of the current architecture that we have would be to include some components like node or bench, but we excluded them because they were not covered by components like connection manager, or some of them are not relevant with Bitcoin transactions.
Last time we looked at the conceptual architecture in the peer-to-peer system and style, and we take a look at the differences with the concrete architecture with gaps and divergences. And we found some new subsystems, including the kernel, consensus, interfaces, script, policy, and primitives. And with those new subsystems, we found new dependencies, such as like wallet to policy, which policy provides information about transactions for the wallet, consensus and kernel, where the consensus uses the kernel to access the blockchain and mempool for validation of the system. Kernel and interface, which makes it that the kernel is more user-friendly using the interface. Wallet and primitives, where it helps wallet with key encryption because primitives has the blockchain and transaction information. Policy and script, since script has consensus rules and user signatures, where the policy has information about fees so they can have a dependency for validation phase. And primitive and script, so with the user signatures that are used for validating the blockchain.
So for the concurrency of the system, according to Bitcoin 0.14.0 version release, it has refactored certain P2P network components such as connection manager and peer discovery. So while processing a new block in the blockchain, many delays could now be prevented. And also we can now allow for network activity in the background while message processing is happening. So this increased the throughput and it helps with better validation of transactions in general. So this is the subsystem wallet that we've chosen. And this is our conceptual architecture. And as you can see, the architectural style is a repository style because it relies on a central database component to store all the relevant information. And for the concrete architecture, we added some new components, as you can see highlighted in red, and new dependencies highlighted in the red arrows. So after analyzing the divergences, we came up with new subsystems such as coin selection, spend transaction, wallet DB, and coin control. And with that, we also derived some new dependencies. So first one is fee to coin control. So the fees component calculate the fee for a transaction, and it has to access the coin control to update the change in Bitcoins. The second one is WalletDB to external signature. It accesses the external signature to get the user signatures in order to generate public and private keys for an encryption for a transaction. Also, for the last one, received the transaction, the received money is confirmed by the received component, and it can also verify with the transaction component and guarantees the non-repudiation NFR because the sender cannot deny that it has sent money.
For use case 1, we look at the case of making a transaction where the user will request the transaction with the application and get a connection with the connection manager, where it will use the public keys within the wallet and virtual transaction size to policy and get the transaction with the consensus to verify everything and return the keys, where then it'll create a request to send the transaction with the TXS and queues the transaction, where mempool will go through the validation transaction in the validation engine, where then after being validated, it'll update the chain and confirm the update to the storage engine, and will return the transaction hash all the way back to the connection manager.
So in the second use case, the user participates as a node in the P2P network. So first, it will request a connection to the application, which will then send a request to establish a connection with the connection manager, which will then call the peer discovery component to scan the network for nearby peers. After that, it will update the list of peers to the peers component after it has found a certain amount of peers. And then after that, it will start getting the get key pub key method to the wallet component, which will then call certain methods like ctxin and cscript witness, which are basically getting necessary information for the encryption. And then after that, it will return the keys to the connection manager.
So lessons learned for this part of the project is taking a look at the concrete architecture and conceptual architecture to understand the gaps and differences between them, and perform reflection analysis on the whole system and subsystems to see how they evolved and the differences, as well as we learned about time management of our group work. And in conclusion, we used reflection analysis on the system, and we specifically explored the wallet subsystems to see it was a repository architectural style. And we used all this information to improve our diagrams and understanding of the Bitcoin core overall. Thank you for listening.
Yeah.